Good evening, my dear students. Welcome to IMS Academy. Hi, I am Vipin Mishra and you are watching the PYQ series of IMS Academy. So this is going to be the lecture number 4 and we are going to discuss the question of year 2020. Okay, up till the lecture number 3 we have already discussed the questions of year 2023, 22 and 21. Okay, so yesterday we discussed the questions of year 2021 and today in this lecture we are going to discuss the questions of year 2020. Okay, and specifically we will be discussing the questions of power system and power electronic. Now at the year 2020 the electrical paper was a little tough one. Okay, so what type of questions were asked? So that I'm saying that the paper was a little tough on a little tougher side. Let's see, okay, whether it was really a tough one or it was just a matter of time. If you are well prepared for the exam, so it was overall it will not be a tougher one for you. Okay, so just see what type of questions have been asked in 2020. Okay, so why I'm keeping this on the tougher side? Because questions were not usual that we normally used to see in the exam. For example, just see. This was a question related to Y bus matrix, okay? And what has been asked here is two buses I and J are connected with a transmission line of admittance Y, at the two ends of which there are ideal transformers with turns ratio as shown. Bus admittance matrix of the system will be what? So normally, good evening Thirumala, welcome to IMS Academy. So normally, we are habituated in forming the Y bus matrix just by doing the inspection method. But if we see something like this, which is not a usual condition, we are in a problem. Okay. So if you have practiced that, suppose if there is a transformer in between two buses, how we will be writing the Y bus, then it's a very simple question for you. Okay. So how to solve a question if suppose the buses have a transformer in between? It's very simple. And what trick I have told you in yesterday's lecture as well? I have told you that if suppose you are getting anything unexpected, what you have to do? You have to apply KVL and KCL while solving the problems of bus admittance matrix. So if you have listened me carefully and you have adopted this strategy, this problem is not going to create a problem for you. Okay, just see how easily we can solve this question. So what has been given to us? We have been given that we have two buses. Okay, so we have two buses and in between two buses, if suppose we only have an admittance, that is not a problem with us. In between two buses we have the transformers. Okay, so which is going to create a problem for us. Okay, so just see, we have transformers in between the buses. The bus number I has a voltage I, VI, and bus number J has a voltage VJ. Okay, and this is the admittance connected in between them. So this is the value of admittance which is connected in between these two transformers or in these two buses. Now the transformation ratio of this bus is 1:Ti and the transformation ratio of this bus is Tj over 1. Okay, Tj to 1 is the ratio of transformation ratio of this particular transformer. So this is what is given to us. Okay, now how to solve these kind of questions whenever we are in this kind of situation, how to deal with these problems? So just see what I am going to do here. If this is voltage Vi, then probably this is also going to be the voltage Vi. Okay, then let me call this voltage to be V1. Okay, and if this voltage is V1, if suppose this voltage that we have here is Vj, let me call this voltage to be V2. Similarly, if the current here is II, then what will be the current here? Let me call this current to be I1. Similarly, if the current here is Ij, then what will be the current here? Let me call this current to be I2. So similarly, okay, at both the end of the buses, we have assumed the voltages and current. Now, how these voltage and currents will be transformed? They will be transformed as per the ratio of the transformer. Okay, so if I simply write for this transformer, what will be the expected transformer ratio? 1:Ti. So if I will be writing here, what will be V1 over Vi, then I will write it Ti over 1. Okay, or simply I can write it that V1 will be equals to Vi into Ti. So this is how I can find the voltage V of 1. Okay. Now, if I apply the same thing with the current, so what I will get for current? If I write here I1 upon II, so that will be equals to 1 upon Ti. So from here I can find that I1 will be equals to II over Ti. So I have found out the voltage V1 and the current I1 through this transformation ratio. Okay. Similarly, if I do it for the transformer 2 that we have, so for the transformer 2, what will happen? What will be the voltage V2 over Vj? V2 over Vj simply will be equals to Tj over 1, or what we can write here is that V2 equals to Vj into Tj. Similarly, I can write it for the current as well. So for the current, what I will be having? For the current, I will be getting I2 over Ij. That will be equals to It over Ij. That will be equals to what? 1 by Tj. So from here I will get I2 to be equals to I of j divided by T of j. Okay. So just see. First what I have done, I have marked the different currents on different side of the transformer. Then I have calculated those currents. So this is a small exercise you have to do whenever you have transformer between the two buses. Okay. Now half the job is done. Okay. Half the job we have already done here. Now what we have to do? Just see. So now I know the voltage V1, now I know the voltage V2, I1 and I2 in terms of the transformation ratio. Okay. So if I have to write the current I1 here, how I will be writing the current I1? Just tell me. How I will be writing the current I1? So just see here. You know how to write the voltage and current in terms of admittance. If suppose I have I will be writing I to be V by Z, or 1 by Z is Y. So in terms of admittance, the current is written like I into current is written like voltage into admittance. So if I have to write for current I1, it will be what? It will be the voltage across this particular transmission line, which will be V1 minus V2 times the admittance, isn't it? So how I will be writing for the current I1? So if I have to write for the current I1, I will write I1 to be V1 minus V2 times Y. Yes or no? It will be V1 minus V2 times Y. Now it's time to put the values. So what is I1? I1 is II upon I1. If I want to write I1 is II upon Ti. Okay, so I can write it II over T of I. And if I have to write for V1, so what is the value of V1? V1 is Vi Ti. So let me write here Vi Ti minus. When I have to write for V2, V2 is Vj into Tj. So let me put here Vj into Tj times Y. So what will be the value of II from here? What will be the value of II? You have to multiply this Ti on the right hand side. So what I will be getting? I will be getting here Ti is square into Y times Vi minus. I will be getting Ti Tj times Y Vj. Okay, and let me call this to be equation number 1. Okay, let me call this to be the equation number 1. So now I have found out an equation in terms of II and Vi and Vj, which are the voltages given to us. Okay, now similarly you can see that I1 and I2, they are the same current but they are flowing in opposite direction. So simply I can write here that I2 is nothing but minus of I1. Yes or no? So I2 is nothing but minus of I1. So we have I2 which is minus of I1. Okay. And if I have to write I1, what I will be writing for I1? Just see here. I1 is II upon Ti. So let me write here II over Ti. Okay. Now what value of II we have obtained in equation 1? Let me put that value. So it will be 1 upon Ti, and let me write the value of II from equation 1, which is Ti square into Y Vi minus Ti Tj Y into Vj. Okay, so multiply this inside, and what we will be getting? We will be getting here minus of Ti into Y V of I, okay, minus of Tj into Y into Vj. Just see here. This is what we are getting. Any change that you want to do here? We have obtained I2, which is equals to minus of I1. Okay. So I2 is equals to minus of I1, and this is what we have obtained. Okay. Now we have something for I2 as well. I2 is basically Ij upon Tj. So let me write here Ij upon Tj here for I2. Okay. So then finally what will be my I of j? So if I just send this Tj on the right hand side, what I will be getting is, and this will be plus here. So I will be getting minus of Ti minus of Tj into Y into Vi plus Tj square into Y into Vj, and this will be my equation number 2. So if you see right now, I have to obtain the bus admittance matrix, and bus admittance matrix is being obtained through the equation in terms of bus current and bus voltage if it is written like that. So just see here, I have written in terms of the bus current. II is the bus 1 current, Ij is the bus 2 current, and the voltages that I have is Vi and Vj, bus number I and bus j voltages. Here also I have Vi and Vj, which is bus number I and j voltages. Now if I write them in matrix format, what I have obtained, just see there. So I have II and Ij, when they are written in terms of matrix, what I have obtained, just see here. So in terms of the voltages Vi and Vj. Okay. So from this equation, what we have to write here? I will be writing here Ti square into Y, and then I will be writing minus of Ti Tj into Y. Is that fine? This is what we get from equation 1. Now from equation 2, I have minus of Ti Tj into Y, and then the other term is Tj square into Y. Okay. So now just see. What I have obtained is, this is my bus current and this will be my bus admittance matrix. Okay, and these are my bus voltages. Okay, so what is my bus matrix? So my Y bus matrix in this case will be T of I square into Y. Okay, in the diagonal element I'm having Ti square and Tj square Y, and in off diagonal element both the elements are same, which they have to be because we are obtaining Y bus matrix. This is how you can recheck whether whatever you have done is correct or not. So you can see the diagonal element, off diagonal element that we have are exactly same here because it is a 2 cross 2 matrix. So whatever Y12 we have, the same is Y21. Okay, and these will be my diagonal elements. So this is how easily we can find out the Y bus matrix. Again, the same trick. In the year 2021, we also had a question in which it was impossible to form the Y bus matrix just by looking into the circuit diagram or just by doing with the inspection method. But and how we have resolved that problem? By applying KVL and KCL. Similarly, here also what we are doing? Applying KVL and KCL. Okay. So if transformers are there, they will transform the voltages. Small thing you have to understand here. So which option is correct here? Which option will be the correct option? So as per the answer we have obtained, option number D is the correct answer. So just see, this is how you can very easily find out what will be the bus admittance matrix of this case. Now this problem may be repeated as well. Instead of 2 transformer, you may be having only 1 transformer. Instead of 1:Ti, Tj:1, you may be having other ratios as well. Okay, this may be a numerical value as well. So this results, whatever you have obtained, you can practice this result and you can apply in the questions if you have anything other than this. Okay, so this is how you could have solved this problem very easily. Okay, so if you don't know how to resolve the transformers, that was a struggling question for you. If you have practiced that particular concept as well, this would have become a very easy one for you. Okay, now moving towards the next question. I hope you have understood this question. If you have any doubt in this question, or if suppose you are not able to understand anything regarding to this particular question, you can comment on the comment box. Okay, now just see this question. This was also a very good question. A lossless transmission line with 0.2 per unit reactance per phase uniformly distributed along the length of line connecting a generator bus to a load bus. Stop here. What is given to us? We have a generator bus, we have a load bus. Okay, so this is the generator bus and this is the load bus. They are connected to each other with a transmission line which is having an impedance of 0.2 per unit. So what is the impedance of transmission line? The impedance of transmission line is 0.2 per unit. So this is what is given to us. Now it is protected up to 80% of its length by a distance relay placed at the generator bus. Very good. The generator terminal voltage is 1 per unit. So generator terminal voltage will be the pre-fault voltage and it is given to us, which is 1 per unit here. Fine. There is no generation at the load bus. So at the load bus there is no generator. The threshold per unit current for operation of the distance relay for a solid 3-phase to ground fault at the transmission line is closest to among which one of these. Okay, so they are talking about a solid 3-phase fault. So in 3-phase fault, what is the fault current? Okay, and what they are asking, the threshold per unit current for the operation of the distance relay. When the relay will operate, when there will be a fault and the current flowing more than the normal value, then relay will sense that particular fault current and it will trip the circuit breaker. And this is how the faulty section will be removed with from the healthy section. Okay, so how to find the fault? How to find the 3-phase fault current? So 3-phase fault current is basically equals to E of F upon XTH. Okay, so E of F is 1 and XTH. In place of XTH, we only have the transmission line impedance. So this is how it will be 5 per unit. Okay, and this is when you have used 100% section of transmission line. Okay, this answer we will be getting when we have used, when 100% transmission line is being utilized. Okay, so when we are utilizing the 100% section of the transmission line, this is how we have to find the fault current. But what we are doing exactly in this problem is connecting a generator bus to a load bus is protected up to 80% of its length. Okay, so we are giving only 80% protection to the transmission line. Just see, like this. So we have generator and we have load and we have protected only 80% section. Okay, so total transmission line impedance is 0.2 per unit. So how much will be the XTH right now? Only 80% section of the line is protected. So 80% of 0.2, which will be 0.16. So what will be the new fault current? So the new fault current will be similarly E of F divided by X of TH, which is 1 upon 0.16. So you will get 6.25 per unit. So this is the fault which you will be getting if you have protected only 80% of the line section. And if you have protected only 80% of the line section, this is the fault current flowing, and your relay will be sensing this current. So this will be the threshold current for the relay, okay, which is also given in option number B. So option number B will be the correct option, okay. So you just have to go with the flow of the question and you will guess what you have to do when you will read the question only, okay. So normally how we find the fault current? Simply doing EF by XTS. So this is the normal fault current, which is 5 per unit, okay, when 100% of the line is protected. When you are only protecting 80% of the line, fault current is 6.525 per unit. So as per the 80% of line, the XTH will have a new value, and as per this new value you will calculate the new fault current, okay. So this will be the fault current on which the relay will be operating now, okay, not as per this particular current. This will be the current when 100% protection section is being protected. So what exactly was the problem with this question? Nothing, isn't it? So you only have to go with the flow of the question. You have to be very much conceptually clear, and you can easily solve the gate questions, okay. Now this question may also be getting repeated. In place of 80%, they may give other percentage, and they may ask you to compare these two cases. Means they may ask you about the ratio, okay, or the difference in the fault current, okay, from pre-protection to the post-protection condition. So this question may be repeated in the 24 year 24 as well, okay. Now moving towards the next question. So just see this question. This is my favorite one. What has been given in this question, and what I have seen most of the students struggle in this question. Why this is so? Just see. So we have bus 1 with voltage magnitude V1 1.1 per unit is sending reactive power Q12 towards bus 2 with voltage magnitude V2 equals to 1 per unit through a lossless transmission line of reactance X, which is given here. So what is V1? V1 is basically 1.1 per unit. How much is V2? V2 is given 1, and bus 1 to bus 2, the reactive power transfer is Q12. The transmission line is having a reactance of X, okay. Keeping the bus voltage 2 fixed at 1 per unit. So bus 2 voltage remains fixed as 1 per unit, okay. So this is the case 1 that we have. So in case 1, why don't we first find what is the Q12? Okay, so let's find Q12 in case 1. So this is the case 1 that we have. Now in this case 1, what will be the Q12? The reactive power transferred from generating unit to the sending unit, okay. And let me read the problem first of all. Keeping the voltage at bus 2 fixed at 1 per unit, magnitude of voltage at bus 1 is changed. So V1 is getting changed, V2 is fixed in the next case. So that the reactive power set from bus 1 is increased by 20%. So in the second case, when V2 is fixed and V1 is increased, the reactive power transferred from bus 1 to 2 is 20% increased. Real power flow through the line under both condition is 0. Real power flow is 0. That means del value is given to us, which is 0. Okay. What is P? P is E into V, or P is V1 into V2 upon X sin del. If P is 0, that means del is 0. Sin del is 0 means del is 0. So del is given 0 to us. The new value of V1 will be what? So we have to find in the case 2 what will be the value of V1. Okay. So in case 1, if I apply case 1, the real reactive power transferred from bus 1 means that the sending end to the receiving end will be what? So for that you will use the formula Vs square. Vs is V1 here. So V1 is square upon X minus Vs into Vr, that means V1 into V2 upon X cos of del. Okay. So what is V1? It is 1.1. So 1.1 is square by X minus 1.1 into 1 upon X cos del is cos 0. So how much we will get? you will get 0.11 over x from here when you will solve it. So this is the Q12 that we have in case 1. Fine, when we have this condition. Now what they are doing in case 2, they are keeping V2 fixed. So in case 2, what do we have? In case 2, we have that V2 is fixed right now and V1 is being increased. So if I find what will be Q12 dash, so this is 20% increase from the past value, means it will be 1.2 times the old value Q12, and through the formula it will be again what? V1 square by x minus V1 V2 by x, cos del is 0. So I am putting cos del equals to 1. Sorry, del is 0, so cos del will be 1. Now just put the values here. 1.2, what is Q12? Q12 is 0.11 over x minus V1 is what we have to find, how much V1 has become, so that 20% reactive power is increased. Okay, minus V2 is still 1. So just see. So we will get one equation in terms of V1. Okay, and what will be that equation? It will be V1 square minus it will be V1 square minus of V1. Okay, and when you will solve it and take it to the this side, it will be 0.132, which is equals to 0. Now we have this quadratic equation. So solution of this quadratic equation, just solve this equation and post your answer in the comment box. Okay, what are the different values we are getting for V1? So the V1 value that we will get is around 1.12. On solving this equation, you will get the value of V1, which will be around V1 that you will get will be around 1. Just solve this quadratic equation and post your answer on the comment box. So 1.12 and the other value will be 0.118, which is not acceptable. So the answer will be 1.112. So when you will solve this equation, you will get these two values, in which the negative value is not acceptable. Okay, so we will take 1.12 as answer. So what is the answer to this question? 1.12. Now tell me what that special thing was that in this question, so that the students have struggled and they are seeing that the paper of 2020 was very tough one. Was it really tough? No. Whatever they are saying in the question, we are just going with the flow of the question and everything is being solved. Yes or no? In the last question also we did the same and we got our answer as well. Okay. So this is a very good question. Okay. This is how we could have managed this question in the exam. Just go with the flow of the question. Whatever they are saying, you only have to deal with one equation, and one equation has given you 2 marks, isn't it? So now see this question. Okay. So this question, what is there in this question? A cylindrical rotor synchronous generator has steady state synchronous reactance of 0.7 per unit. Steady state synchronous reactance means X of D, and it is 0.7 per unit. Then what do we have? Sub-transient reactance of 0.2 per unit. Sub-transient reactance means XD double dash is 0.2 per unit. It is operating at 1.0 per unit terminal voltage. So what is the terminal voltage? It is 1 per unit. 1 plus J0 is 1 per unit. And internal EMF E of F was given to us, which is 1 plus J.7 per unit. Okay. So internal EMF was 1 plus J.7. Following a 3-phase solid short circuit, fault at the terminal of the generator, the magnitude of sub-transient internal EMF will be what? We have to find what will be the value of ED double dash. Sub-transient internal EMF. Okay. So guys, you know, if you have to find out sub-transient internal EMF, this will be equals to the terminal voltage plus J sub-transient current multiplied by sub-transient reactance, means the terminal voltage and the drop into sub-transient reactance. Okay. So in order to solve this question, what data you actually need. We have the value of V, we have the value of XD double dash, but we don't know what is the value of ID double dash, and there is no hint given for that as well. But through this data, we can calculate one thing, and what is that? We can calculate ID. So ID will be what? If we apply the same relation for steady state voltage, so it will be E of D, this will be equals to, or we will write it, why I am writing it ED double dash, it should be EF double dash. Okay, so if I write the same equation for the steady state model, it will be E of F equals to V plus, E of F will be equals to what? V plus, or if suppose I have to find the current ID, what I will be doing, I will be writing this equation, that it will be E of F minus V divided by XD, okay, divided by XD. So what I will get? E of F is 1 plus J 0.7 minus V is 1 divided by XD is J 0.7. Okay, so what I will get? I will get 1 per unit of current. So just see, by applying the steady state model, I have obtained the current ID. Now we also know that ID double dash is greater than ID dash greater than ID. Subtransient current is having the highest value than the transient than the steady state value. But unfortunately, we don't have other data to find out the value of ID double dash. So we are forced to choose ID double dash and ID equal to each other. So this ID what we have obtained, we are assuming that this is equals to our ID double dash as well. So if you know that EF double dash will be equals to what? V plus JXD double dash into ID double dash. Now we have all the data. What is V? It is 1 plus JXD double dash is 0.2. ID double dash is 1. So what you will get? You will get 1 plus J 0.2. That will be my E of F double dash. But I have to find out the magnitude. So what will be the magnitude? The magnitude will be 1 plus 1 square plus 0.2 square. So you will get 1.02 per unit, and that will be the answer. Okay. So just see, we have to find this. Okay. We have to evaluate this, and for this is the unknown thing that we don't know, and there is not enough data given in this question to find out this. So what we have done here, through the given data, I have found out what will be the value of ID, and I have assumed that all these three currents, ID double dash, ID and ID dash, are equal to each other, because there is no other meaning of calculation of ID double dash. So I can assume that these currents are equal. Okay. So this is how I will find out EF double dash in this question. So this was not at all a tough problem, but we have to assume something here. So students was struggling in this question with this fact. No ID double dash is given. How to find ID double dash? Okay, so we have to assume that ID double dash is equals to ID dash here. Okay, if we are stuck in such a situation, we can assume that. So this is how you can solve this question as well. Now in the next time, you may be asked to calculate the ratio of ID double dash to ID, EF double dash to EF. Like that questions will be asked, and this is how you have to resolve those kinds of question. Okay, is that clear? If it is clear, just post your comments on the comment box and tell me what else we can do to find ID double dash, if we have any other method. Now moving towards the power electronics. So just see what question we have from power electronics, and specifically from inverters. So a single phase inverter is fed from a 100 volt DC source and is controlled through a quasi square wave modulation scheme to produce an output voltage waveform VT shown. So what type of inverter we have? Single phase inverter. Okay, fed from 100 volt DC. So VDC is 100 volt. Let me write it here. The VDC voltage is 100 volt. Okay, it is a single phase inverter, and the output that we are getting is a quasi square wave kind of output voltage. Okay, the angle sigma is adjusted to entirely eliminate the third harmonic. So this angle sigma is adjusted in such a way that third harmonic is not there. So if third harmonic is not there, that means V03 is 0. Okay. So we have V03 is 0. Third harmonic component from the output voltage. Under this condition of Vt, the magnitude of the fifth harmonic component as a percentage of the magnitude of the fundamental component will be what? This is what we have to calculate. So as per the given data, okay, if we have quasi square output voltage, what is the Fourier series expression for nth voltage? So this will be summation n equals to 135 to infinite 4 VDC over n pi sine n pi by 2 sine nd sine n omega t. That is the Fourier series expression that we are having. Okay. Apart from that, it is mentioned here that we are not having any third harmonic component. Okay. So you know that to eliminate nth harmonic, okay, what could be the pulse width? The pulse width 2D has to be 2 pi over n. Okay, so here we are having third harmonic which is being eliminated. So what we will get? We will get 120 degree. That means that the D value will be 60 degree. Yes or no? So through the given data we can obtain the value of D. And if you are an electrical student and you are going to appear in GATE exam, you know the importance of this expression. You have to practice this expression. If you don't want to learn it, if you don't want to memorize it, just refer to the lecture number 7 of Excellent Concept Series and you will get to know how easily you can write this expression. Okay. Now what we have to find out here is, that what will be the fundamental, what will be the ratio of the fifth harmonic voltage to the fundamental voltage. Okay. So if we have to calculate the fifth harmonic voltage, we have to put n equals to 5 here in this equation. So it will be 4 VDC over 5 pi sine 5 pi by 2 sine 5d. And if we have to calculate the fundamental voltage, this will be 4 VDC over pi sine pi by 2 sine d. Okay. Now whether it is sine pi by 2 or sine pi by 2, they all have value of 1. Okay. 4 VDC upon pi will get cancelled. What we will be getting here? We will get sine 5d over 5 times sine d. So what you can do, you can put here sine 5 into 60, which is 300, divided by 5 sine of 60, or you will get minus 20 percentage if we talk about percentage, or 0.2. Okay, or you will get 0.2. So 20 minus 20% is the answer. So here what we will be putting here, the ratio we have to calculate. So it will be around minus 20%. Okay, this is how. If you know this equation, you can easily solve the ratio of any harmonic. It may be 7th to 3rd, it may be 7th to 1, it may be 9th to 3rd, it may be 9th to 5th, it may be anything. Okay, this question may be repeated n number of ways. This question can be repeated in n number of ways. It can be asked again in the exam just by modifying this question. And what you have to do? You have to just remember this equation. This is a very important expression if you are a GATE aspirant. Okay, this is a very important question for you. Okay, and let me tell you a trick. For any particular value of, for any specified value of D, okay, if you have to calculate any V0 nth upon V0 fundamental, okay, the ratio of it will be 1 upon n. Okay, so this is a trick. If you have to calculate the nth order voltage to the fundamental ratio, it will always be 1 by n. So here what we have done, here we have calculated, just see, this is a trick that you can use. Here we have calculated the ratio of fundamental voltage to the ratio of fifth harmonic voltage to the fundamental voltage, isn't it? Ratio of fifth harmonic voltage to the fundamental voltage is what we have calculated here. And what is it? It is 1 by 5. Similarly, 7th to fundamental 1 by 7, 9th to fundamental 1 by 9, 11th to fundamental 1 by 11 for a specified value of D. Okay. So this you can use as a trick, and next time you will not have to solve this entire question. You can apply this trick and it will be solved for you. Now this is valid only for if you have to find the ratio of any of the harmonic with respect to the fundamental. If suppose instead of we are doing V05 to V03, this is not the case which you have to apply. So this is only applicable when you have to find the particular harmonic ratio with respect to fundamental. Okay. So you can see if you have applied this particularly here by reading the formula 1 by 5, this means minus 20. So you could have easily solved this question, isn't it? So what was the problem with this question? Now most of the students, they are horrified with looking into this waveform. But if you are a power electronic student, you are most aware of it. You are habituated of seeing this waveform, quasi square wave. You need to practice how to write the expression for a quasi square wave kind of waveform. If you are through to it, you don't have any problem on solving these kind of questions. Okay. So let me move to the next question. So this is the next question that we have. If you are a power electronic student, you know that there will definitely be a question from the source inductance, effect of source inductance in rectifier. And in that year we had a question consisting 2 marks. And what has been given here is, we have a single phase full bridge fully controlled thyristor rectifier feeds a load comprising of 10 ohm resistance. So what is the value of load resistance? Load resistance is 10 ohm. In series with a very large inductance, the rectifier is fed from an ideal 230 volt 50 hertz supply. F is 50 hertz and Vs is 230 volts. So what will be the value of Vm maximum voltage? It will be root 2 into 230 volt. Negligible internal resistance and a total inductance of 2.28 Henry. So source inductance is given 2.28 millihenry. If the thyristors are triggered at an angle of 45 degree, so if the firing angle is 45 degree, what will be the commutation overlap angle? We have to find what will be the value of mu. Okay. So what type of rectifier it is? It is a single phase full bridge rectifier. Okay. So how to solve these kind of question? You have to do the very first thing, which is write the expression for V0 new. Okay. What will be the new V0? So it will be equals to V0 old minus the reduction in the output voltage. So if we have source inductance, you must have read in the class that there will be a net reduction in the output voltage. Okay. So what will be the new voltage? Old voltage minus the reduction. Now what is the old voltage? In a single phase full bridge rectifier, the old voltage or the output voltage is always 2 Vm by pi cos of alpha minus. How much will be the reduction for this rectifier? For this rectifier, the reduction will be 4f ls I naught. If it was an half wave rectifier, here you could have written Vm by pi 1 plus cos alpha, and this could be f ls I naught. If this is a 3-phase full wave rectifier, here you would have written 3 Vm by pi cos alpha, here you would have written 6 f ls I naught. Okay. So where you will get this content for what we have to write for and when we have to write, go to the excellent most expected concept series of IMS GATE Academy. It is available in our YouTube channel in the playlist, and you will find the lecture number 10 where we have discussed the effect of source inductance, and you will find how to write the formulas, okay, if effect of source inductance is considered. How to solve these kinds of question? What will be the value of reduction factor in different rectifiers? Okay, so just see. Now V naught mu, if you have to find output voltage, you can find at any time with I naught into R, the current into resistance. Okay, now just put the values. So resistance is 10, so we will get 10 I naught. 2 into Vm is root 2 into 230, okay, divided by pi, which is 3.14, cos of 45 minus 4, F is 50 into I naught, and what will be Ls? Ls is 2.28 millihenry, means 10 to the power minus 3. So if you see, there is only one unknown in this equation, and which is I naught. So when you will solve this equation for I naught, you will get that I naught is equals to 14 ampere. Okay, when you will solve this equation for I naught, you will get I naught equals to 14 ampere. So post your answers in comment box, whatever you are getting apart from this. You all have to get this answer. If you are getting, comment on the comment box. Okay, now after this, after doing this exercise, the next exercise that you have to do is, you have to apply the expression of I naught. So it will be Vm by 2 omega Ls cos of alpha minus cos of alpha plus mu. Okay, so for single phase full wave rectifier, for 3-phase rectifier, I naught expression remains the same. If it was an half wave rectifier, you could have written only omega Ls instead of 2 omega Ls. This is the only change that you will see. Now I naught that you have obtained is 14 amperes. What will be Vm? It will be root 2 into 230 upon 2. Omega will be 2 pi f, 2 into 3.14 into 50. Ls will be 2.28 into 10 to the power minus 3. Cos of alpha is cos of 45 minus cos of 45 plus mu. So we have only one unknown in this equation, and that unknown is mu only. So when you will solve this equation for mu, you will get mu value as 4.8 degrees. So whenever you have a problem related to source inductance, only these two steps you need to perform, nothing apart from this. First, try to calculate the new voltage from subtracting the reduction factor from the old voltage, and old voltage formula is known to you, reduction factor is always known to you, you have to practice that. Then this is the formula of I naught we have to apply, okay, and you will get your answer. So this is how you have to solve these kind of question. So now if I ask you, is that the question that we had in the year 2020, was that really tough? Post your answer in the comment box. Okay, was these questions were really tough? Just post your answer in the comment box. And if you were the student of 2020, how much marks you have scored in that paper if you could have obtained these kind of question? And if suppose in 2024 you are getting the same kind of question, is there any difficulty that you will face in solving these question? As far as I am concerned, you don't have to. Okay, so post your comment on the comment box whether these questions were really tough or it was a very easy one, isn't it? As a GATE aspirant, you must be expecting these questions to appear in the exam, and it was really the same case. Okay, so this is the end, and we have discussed the questions of year 2020. Now I will be back with the question of 2019, then question of 2018. Okay, so by joining our channel, by joining these videos, you can solve all the PYQs of power system and power electronics together with me here. Okay, the PDF of this section will be made available on the Telegram channel, and you have to join that particular Telegram channel, and from where you can join the Telegram channel, the link is given in the description box. So through that link you can join our Telegram channel. There I will post this PDF what we have discussed today, the PDF of the solution along with the question I will paste there. So you will get the PDF as well, and you will get a regular feed about the GATE exam as well. Okay, you will get to know more about GATE exam. You will be getting so many good questions there regularly that you can solve and have a better practice of GATE exam. So everything will be there in the Telegram channel. So description of that, the link of that Telegram channel is given in the description box. You can join through that our Telegram channel. So thank you everyone. Thank you for attending this session. I hope you really liked it and I hope you have really enjoyed it. Thank you so much.